In this lesson, we're going to work on solving inequalities using addition or subtraction. And of course, that is exactly what our objective is. We want to be able to solve an inequality. We're going to use adding or we'll use subtracting to do it. Straightforward pieces that you're likely familiar with. Inequalities are things that don't use an equal sign. So inequalities would include less than, greater than, less than or equal to, greater than or equal to. And we can convert them between the written inequality and its words and the graph. If we'd like to graph here, x is greater than 4, we would simply be able to say, well, instead of reading it as x represents all numbers. So in terms, we would say all numbers greater than 4. For its graph, we know that the graph will be centered around the number 4, so we'll definitely need to have something, say 2, 3, 4, 5, 6, 7. And since we have greater than, not greater than or equal to, that is, because there's no line written there, not having the line for or equal to tells us that we should have an open circle on our 4. Whoa, back that up. Open circle on 4, and then we'll fill it in for numbers that are greater. Likewise, if we're going to write this out for number 2, all numbers less than 5, well, all numbers is our variable. This time I chose the variable m. All numbers less than 5. Done. To create its graph, get some tick marks down. 1, 2, 3, 4, 5. And we could have had 6, but 7. We just have to make sure that we need to have step 5 in it. Since we're looking at numbers that are less than 5, less than goes to the left. Got it. Progressing to the third one. Well, when we look at this one, we should observe we've got our dot over on the 4. And because this 4 is filled in, that's telling us that we would have something that would be less than or equal to. It could be greater than or equal to. But when we observe that it's going to the left, that should tell us that we've got our variable less than, because the circle's filled in, less than or equal to 4. And so we'll write it out in words. All numbers less than or equal to 4. And there we're finished. This type of skill of writing an inequality, of course, bears a role with pieces like in science. Really simple question. Water, we know, freezes when its temperature is less than 0 degrees Celsius. So write the temperatures for frozen water, that is ice, as an inequality. Well, right here, when it's less than 0. So the temperature has to be less than 0 degrees Celsius. We're done. Progressing forward, we would want to be able to add and subtract to solve an inequality. Now, of course, we have had similar problems like this already. We have seen problems before that look like t plus 4 equals 5. And we saw that when our goal was to isolate the variable by itself, all we would want to do is to subtract off to cancel out the addition, and that left us with our answer t equals 1. Solving an inequality is no different. Our strategy is still to isolate the variable, so we still have the same goal of getting rid of adding 4. So our work is going to look virtually identical. Subtract 4. 5 subtract 4 gives us 1. And really the only difference was that we are using the inequality greater than instead of the equal sign. Also, pay attention to your directions. These directions simply told us solve the inequality. We did that. But you will frequently encounter directions that will say solve the inequality, and then the directions tell you to go further and say something like, then graph its solutions. Well, when you pay attention to the directions and they tell you to graph the solutions, you absolutely have to graph the solutions. We would have to then create a number line, and because we've got the number 1 in there, let's say negative 1, 0, 1, 2, 3. We just have to make certain that we've got the 1 included. That's where our focus is, right on the 1. Because it's strictly greater than, we will not fill in the circle. And also because it's greater than tells us to go to the right, getting the bigger numbers. There we go. If asked to solve, or rather if asked to graph, we have to graph the solution. We'll also note this particular one is set up the same way. We could look at it and say to cancel out the subtraction of 12, to subtract 12, we know that subtraction has to be paired with addition. Negative 10 plus 2, that will equal 2. Leading us to our answer, 2 is less than or equal to x. A lot of times, this would be okay to stop. This does give us our answer. It's very unusual, though, to write inequalities with variables on the right-hand side. It's not a form that we particularly like. It is greatly preferred that we would flip this piece around and make sure that our inequality starts with a variable on the left. It's easier to understand, it's easier to interpret, it's something that we drastically prefer, and I do expect you to finish it, and I do expect you to write your variables on the left. Quite simply, we just have to make sure that when we flip an inequality around, that we flip the inequality along with the sides. Our inequality was originally pointing at the 2. Well, 2 is less than x is the same thing as saying x is greater than 2. And this piece down here in the purple, that's how I expect you to write your answers. And if we were asked, this particular one did not ask us to graph it, but remember, if it does, we just have to make sure that somewhere along the lines, we get the number 2 included, because the circle is going to go over it. Because it's or equal to, the number 2 should be included in our answer, and so we'll fill it in. And since we're looking greater than 2, 3, 4, and 5 are greater than 2, so we'll fill it in, and there's our answer. Here's our last example for the day. Let's suppose you're competing in a triathlon, and your goal is to beat Fry. He completed the swimming section of the triathlon in 12 minutes, the biking section in 25 minutes, and the running section in 16 minutes. We'll be able to observe then that if we take the 3 sections for Fry, we should be able to put those together. 12, 25, and 16. We'd be able to add the 3 sections to get their total time, or his total time. 37 plus 16 gives a total of 53 minutes. So essentially, since your goal is to beat Fry, that means your goal is to finish faster than 53 minutes. Now, please consider this. If your goal is to finish faster than 53 minutes, is your goal to finish less than 53, or is your goal to finish greater than 53? Since your goal is to finish in less than 53 minutes, we would be able to look at it and say your swimming section combined with your biking section combined with your running section should be less than 53 minutes. Now, what do you think? Should it be strictly less than, or should it be less than or equal to? And what makes you think that? If your goal is to win, that means you don't want to tie. And 53 minutes would be a tie. So since we don't want to tie, we don't want equal, we want strictly less than, strictly better than Fry beating. Recognizing this relationship would allow us to put these things together and say, okay, you swam in 15 minutes, you did your biking in 24 minutes, and now you've got the running section to be less than 53. Well, of course, we would observe that 15 and 24, your two times that you've used so far, are 39 minutes. So with 39 minutes to go, how much time do you actually have available to do the running section? Well, we'll solve it by subtracting off 39, getting r is less than 14. So what time can you have in the running section? Given the physical constraints, we would normally say, well, I can run in less than 14 minutes. Please keep in mind that it's not possible for you to run in negative time. So we would say you can run between 0 minutes and 14 minutes. Our physical constraint of time prevents us from being able to have negative times. But that's it. We're done. You'll notice each of these pieces on creating an inequality, like with temperature, like with the chart, like with our triathlon, like our triathlon problem, creating the inequality plays a role. Adding and subtracting is the exact same skill we had as when we were solving equations.